Hi, in this video we are going to learn about the trapezium rule. Basically, the trapezium rule gives us an estimation to a definite integral. So if we don't know how to integrate a certain function, then we can use trapezium rule to make an estimation. Let's see an example. So in this example, we have this integral that we cannot integrate within the scope of pure maths 2. So we are going to use trapezium rule to estimate the area under this curve from 0 to 2. So the question says use 4 strips. This means just cut the area from 0 to 2 to 4 strips, so 4 trapezia, and then calculate the area. So let's see how. So first, let's sketch the graph of this function. Now, just because we're going to cut this interval from 0 to 2 into 4 strips, we can go like the difference, 2 minus 0, which is 2, divided by 4. So I'm going to get the intervals of 1/2, right? So it's going to be 0.5, 1, 1.5. You can see that it's 1, 2, 3, 4 regions, so I can have 4 strips. So it's best if I put these values into my table. So if I calculate the y values for each of these x values, I will get the following. And if I write these to my table, it will help me sketch my graph. Of course, I'm not going to go very accurate. I'm just going to sketch it, but I'm going to use this table for my calculations to estimate the value of the definite integral. So the graph of our function square root of 2x plus 3 will look like this. And these are our values, 0.5, 1, 1.5, and 2. Now, where is the trapezium? Well, the trapezium is here when you join these 2 points. And then when you join these 2 points and these 2 points, you can see that it's going to be a good estimation because we're not ruling out too much area outside our trapezia. Now let's start calculating the areas. I'm going to name the trapezia like T1, T2, T3, and T4. Now the area of trapezium is the sum of the parallel sides multiplied by the height divided by 2, because we use triangles to find the area of trapezium. That's why we're dividing by 2. Now, my parallel sides for T1 would be these. So I know that this is 1.732 and this one is the value of y for 0.5. So that's going to be 2. So I'll go for T1, 1.732 plus 2 multiplied by the height, which is 0.5, divided by 2. This is the area for T1. To calculate T2, I need to know this length, which I do. It's 2.236. So for T2, I'm going to go like 2, this length, plus this length. So 2.236 times 0.5, because that's the same height here, from 0.5 to 1. And for T3, I'm going to write 2.236 plus, now it's going to be this y value for this length, 449 multiplied by 0.5 and divided by 2. And the last trapezium will be, it's going to be this and this, so it's going to be this and this value. So I'm going to add 2.449 plus 2.646 multiplied by 0.5, which is the height, divided by 2. So if I calculate each of these areas and add them, I will get a good estimation for this definite integral. So basically, this is the trapezium rule. Now let's generalize this idea. To do that, I'm going to add those areas before calculating. So it's going to look like this. And let's take the common factors out. First of all, each of them are divided by 2. So I can take 1 over 2 out. And also, I'm multiplying each sum by 0.5. So I can take that out. It's also here, right? So I will write 0.5 out. And let me write now, it is all addition. So I can go like 1.732 plus 2 plus 2 plus 2.236. So I've written these so far. And plus 2.236 plus 2.449 plus 2.449 plus 2.646, and that's it. Now, let me simplify this a little bit. It's going to be 1 over 2 from the fraction, 0.5 is the height, and you can now notice that the sum here has some repetition. So we have 2 repeated twice, 2.236 repeated twice, 2.449 repeated twice. So the first one and the last one are only once, but the others appear twice. So what I can write is 1.732 plus 2 times the other numbers, 2 plus 236 plus 2.449. So these are the numbers that repeats itself 2 times. So the last one at the end, 646. Now, you can give it a try with more than 4 strips, or you can try with another function, with another table. You will always get the same pattern. It's going to be 1 over 2 for the fraction multiplied by the height, and for the vertical side lengths, which are the y values, by the way, remember the table that we made, the first value and the last value appears only once, and the other values in between, they appear twice. So we just take 2 out as a common factor, and we end up with this formula. An integral of a function is approximately equal to 1/2 of the height times this sum. As I explained before, the first and the last y value appears once and the others appears twice. So they are in the brackets with a common factor 2, right? And the height is given to be the difference between the borders divided by the number of strips. So this is where the formula comes from. And luckily, in the formula sheet, you are going to have this formula given. So you don't need to memorize anything. You can just fill out your table, and then you can just write the y values inside, calculate the height as given, right? And you can just calculate this, finding an estimation for the definite integral. And in our case, this calculation will give us 4.437 up to 3 decimal places. And considering the fact that the actual definite integral from 0 to 2 is 4.441368 and so on, you can notice that it is a really good approximation. And this is just with 4 strips for trapezia. So if you increase the number of strips, then you're going to get a better estimation. Now in this example, I showed where the formula came from. I'm going to solve another example properly with the use of the formula. So we're going to use the trapezium rule this time to estimate this definite integral. So here, the function is y equals 1 over x squared plus 1. And sometimes instead of writing 1 over x squared plus 1 dx, we just write it like this. Because this is an algebraic expression, dx, that is. So you can multiply it with numbers or other terms, right? So we can see these in our books, dx over x squared plus 1 within the integrals, right? Now, to go on with my estimation, I have to calculate the area for each strip. And to be able to do that, I have to make a table. So I need to know which x values I have to substitute. Now, if I am asked to use 4 strips, then I'm going to calculate the height like this. It's going to be the bigger border minus the smaller one divided by 4 strips. It's going to be 2 over 4, which is 0.5. This means my interval from 1 to 3 must be divided into pieces of 0.5. So it's going to be 1.5 and then 2 and then 2.5 and 3. So these are going to be my x values in the table. You don't need to show work to fill in the table. You can just use your calculator and do your calculations. When you do that, you're going to get the following y values. Now, unless specified, the rule of thumb is that you write your values up to 3 significant figures where you need rounding. You can see that for the x values 1, 2, and 3, I get really nice decimals, so I just keep them as is. But the others, for 1.5 and 2.5, I rounded them up to 3 significant figures. Now, let's clear this up a bit and use our formula. So this definite integral from 1 to 3 of dx over x squared plus 1 is approximately equal to 1/2 times the height. Now you can see that the height that we calculated is 0.5, so I'm going to write it as 0.5. If you'd like, you can write the fraction. And then I'm going to start writing the y values. The first y value will be 0.5 plus, and then remember we were writing 2 times in brackets the y values in the middle. It's going to be 0.308 plus 0.2 plus 0.138, and then I closed brackets because the last one will be outside the brackets again. It's going to be 0.1 in addition here, and then it's just a use of a calculator. Now I prefer to calculate here separately, saying that it's going to be 1 over 2 times 0.5, which is going to be either 0.25 or 1 over 4. That's my preference, but decimal is okay. In brackets, I just calculate whatever is inside the brackets, which is 1.892. And when you do the multiplication, you end up with 0.473 as your estimation. So basically, all you have to do is to make a table. You don't even need to sketch the graph. You just make a table. Of course, to be able to make a table, you have to know what's gonna be the difference between those values. So if you have the borders, you're going to use the formula for h, which was b minus a over the number of strips. That's what we did. 3 minus 1 over 4. We ended up with 0.5. So that's how I find my x values. I start with 1, adding 0.5, I get 1.5, and then 2, 2.5, and 3. And then I calculated the corresponding y values for each, and then I just simply use the formula, right? So this is just an estimation, and this is what we are supposed to do when we are asked to use the trapezium rule. Now, if you are given a table with some missing y values, you can just find the difference between, let's say, 1.5 and 1, and instead of using the formula, you can just end up with 0.5, which is the height, just finding the difference. You don't need to use the formula if you are given a table, right? So you don't need to use the formula. And then you just find the missing y values and use the formula, and you're done. So this is pretty much how we use the trapezium rule to estimate the definite integrals. Thanks for watching.